Hello and welcome to Amazon Web Services webcast, AWS Lambda, Best Practices, Python, Scheduled Jobs, and more. Before we begin, I would like to walk the audience through a few items. On your screen, you can see a Q&A pod. Please submit your questions for our presenter at any time. Our presenter and Q&A moderators will address them in the live Q&A session, as well as throughout the live presentation. At the conclusion of today's webinar, there will be 3 poll questions proceeding live Q&A. Today's webinar is being recorded, and we will send you a follow-up email with a URL to the recording once we verify the recording quality in the next few days, as well as a link to the presentation copy. And again, welcome to today's webinar, AWS Lambda Best Practices, Python, Scheduled Jobs, and more. Our presenter is Rom Negrani, Senior Product Manager at AWS. Rom is a, hold on, I think there is someone saying I have audio issue. Let me test again. So let me know how they sound now. Let me move the microphone away from me a little bit. Okay, thank you for the feedback. Let me just introduce William, and I'm going to pass the floor to William later. So William is a product manager for AWS Lambda, a compute service that runs your code in response to events and automatically manage the compute resources for you. Lambda helps developers think about applications in a new way by creating simple event handlers that respond to updates from Amazon S3, DynamoDB, Kinesis, SNS, and other services, as well as directly from web and mobile apps. William holds an MBA from the University of Michigan and has previous experience across product management, product marketing, and product engineering. Today with us, we also have Ajay Nair. Ajay is also the Senior Product Manager from Lambda team. Today, Ajay will engage with you and answer questions throughout the presentation while William presents. William, welcome, and I'll pass the floor to you.
Thank you, Bowen. Good morning to everybody from a rainy Seattle morning. And thanks once again to take the time to listen in to the webinar, to today's webinar. My name is Vyom Nagrani, and I'll be your presenter for today. We also have with us Ajay Nair, who will be addressing your Q&A in the panel throughout the webinar. So feel free to ask any questions that you have. We'll be dividing today's webinar into 2 sections. First, I will do a recap of what Lambda is and how it works, and give a quick overview of the benefits of a service like AWS Lambda. Then, for the bulk of this webinar, I will walk through the new features and additions that we announced for this service earlier this month at our annual conference reInvent. I'll walk through how to make use of these features on the AWS console, and also talk to what workloads these features unlock. So let's start off with a brief overview of what the capabilities and working details of AWS Lambda are. AWS Lambda is a compute service that runs your code in response to events and automatically manages the compute resources for you, making it very easy to build applications that respond quickly to new information. Lambda typically runs your code within milliseconds of an event or a trigger that starts the service. The service automatically manages the compute capacity for you and spins up the necessary infrastructure, deploys your code, and then runs a copy of that code for each event. Lambda can rapidly launch thousands of copies of the function to run in parallel as needed to scale to match the rate of incoming events. And performance remains consistently high regardless of the frequency of events. For example, you can trigger an AWS Lambda function to automatically create a thumbnail when an image is uploaded to Amazon S3, if you're using S3 as an event source, as a source of triggers, or to automatically verify address updates in an Amazon DynamoDB table, or to process clickstream data in an Amazon Kinesis stream. Lambda functions can also be invoked directly from external sources, both synchronously or asynchronously, or also respond to API calls made to the Amazon API gateway, which makes it very easy to build backend services to perform workloads such as image analysis, document transformation, indexing, etc. So let's talk about the benefits of AWS Lambda. The first benefit, of course, is that there are no servers to manage. The Lambda automatically runs your code without you having to worry about the underlying servers or provisioning the underlying capacity. All you have to do is write the code and upload it to Lambda, and then Lambda handles everything else. So effectively, you get a serverless compute environment. The second benefit is continuous scaling, where Lambda automatically scales your application by running by horizontally scaling out the number of copies of your code to respond to each trigger individually. This means if you're uploading one image to an S3 bucket, there will be one copy of your Lambda function. If you're uploading 1,000 images, there will be 1,000 copies of your Lambda function. And you get instant horizontal scale that matches precisely the size of your workload. So you don't have to worry about scaling as your application grows. Last benefit is in terms of sub-second metering. With Lambda, you pay only for the actual usage mapped very, very closely to the actual workload that you run. You are charged in increments of 100 milliseconds, and your function size is measured in increments of 64 megabytes. At a very fine-grained level, you are paying exactly for what amount of resources your code is consuming. So let's talk a little bit about the working details of what happens, how Lambda works. So as I said, all you have to do is bring your own code. We support 3 languages today, and I'll talk of Python specifically in a bit. Also, when I say Java here, I mean any JVM-based language. So along with Node and Python, you have the benefit of running applications written in Scala, Clojure, JRuby, etc. And of course, you can bring your own libraries. It doesn't need to be a single file. You can upload multiple files and lots of dependencies and libraries along with the code that you upload to the Lambda function. We have flexible invocation paths. As I talked about, we support both synchronous and asynchronous, or a request response and an event-based invoke options. Also, if you want, you can integrate very easily with the existing AWS services, where you don't have to call 2 different APIs. You just call one API, and automatically that event that you generate on one service will trigger a Lambda function. We have a very simple resource model. All you need to provision, all you need to tell us is how big or how much compute power do you want your function to have, which is specified in terms of the memory limit of a function. We automatically provision CPU and network proportional to the amount of memory that you specify. So effectively, a 512 MB function will have twice the CPU as a 256 MB function. And at the end of each function, we actually report the exact usage that the function consumed, so you can go and fine-tune this setting. We also allow very fine-grained permissions using IAM roles for the Lambda execution. So when the function executes, you can go and specify that this function should only be able to talk to this table in this account. And also we use resource policies for existing AWS event sources, so you don't have to worry about configuring those, especially if you're doing something from the AWS console. Also about how it works, let's talk about authoring functions. With Node and with Python, we have the AWS SDK built in. So if you're doing anything on AWS, you don't have to include the SDK once again on top of the function. That said, if you need something from a different version of the SDK, you're free to go ahead and package anything that you need. Also, you write the code in a way you would write any other application code. You can handle inbound traffic, and you can use any of the system capabilities such as processes, threads, sockets, etc. And you get a 512 MB temp space in which you can write to during the Lambda function execution. For deployment, we have a WYSIWYG editor or a simple IDE type of editor on the AWS console in which you can directly author your Lambda functions. Alternatively, you can package your code as a zip file and upload all your code with your dependencies directly to Lambda console or to S3. And we are also working on lots of other integration here where we have partnerships with CodeShip and similar services where you can use these services to deploy your Lambda functions. For monitoring and logging, we use Amazon CloudWatch. So all your metrics such as your request count, error count, latency of each function, that's the time that the function each takes to execute, and the number of functions throttled are all reported into CloudWatch metrics. And the system as well as user logs for your function execution go to CloudWatch logs. The only thing to note here is that Lambda functions are stateless. So if you need any persistent information, we recommend to use a external persistent data store such as S3, DynamoDB, or Elasticache. And also, since there is no affinity to the infrastructure, you can't quite log into the box. You have to treat the function as an independent copy where you don't really have to worry about where this is running. So I talked about the event sources for AWS Lambda. So let me walk through some of the event sources and what type of applications you can build with each of these event sources or triggers. And I have tried to categorize these by the different types of workloads you could run. This page here talks about the event sources you can use for creating real-time data processing applications. And these includes a lot of the data services of Amazon, such as Amazon S3, where you can run workloads such as image processing, media processing, file processing, anything where you have a file of data that's coming into to AWS and you want to run some processing on top of it. You can upload to an Amazon S3 bucket and have a Lambda function to process that information. Similarly, with Amazon Kinesis, if you have a stream of data, whether it's a click stream or a user input stream or social media feed, all of these can be processed off of Amazon Kinesis. With DynamoDB, you can set up a NoSQL-like trigger. The triggers that you're used to in a MySQL environment, you can now enable in a NoSQL environment using Amazon DynamoDB triggers. You can also process Amazon CloudWatch logs directly as a Lambda function if you want to do a large-scale log processing application for your system logs. And with Amazon SNS, if you're using SNS as a message bus, we can push your information through the pub-sub model, where you're publishing information to SNS, whether information could be clickstream or your mobile application usage or any user information, you can subscribe a Lambda function to that to process this information. So these services or event sources allow you to create real-time data processing applications using AWS Lambda. A second set of event sources that you can use to create web, mobile, or IoT application backends are provided here. Now we have the Amazon API Gateway, which allows you to expose a public RESTful HTTP endpoint, which you can use standard HTTP calls such as get, post to, at the back end, trigger a Lambda function and make, just with 2 or 3 services, a complete scalable web backend for any application that you're running that has an API exposed. You also have integration with other Amazon services such as the Amazon Echo Skills Kit, which allows you to integrate the Alexa to respond to customize Alexa to use and respond using an AWS Lambda function. Similarly, we talked about Amazon IoT Actions. This is a new service we announced earlier this month. And you can have each individual IoT callback to launch a Lambda function in the backend to respond to these IoT triggers. And I will talk a little bit about this as well. We also have Cognito, which allows you to authenticate your users. And every time you have a Cognito sync push to synchronize the information between 2 different devices, you can use a Lambda function to validate this input. Also, we have external integrations where now you can integrate your Twilio application to be customized by triggering a Lambda function in the backend. So all of these event sources, as you see, can make it very easy for you to create customized web, mobile, and IoT application backends. And the last one I want to call out is extensions for existing AWS and Amazon services, or also to create serverless workers. Now, at any point in time, if you're looking for a way in which you need to run a small piece of code to respond or to add a specific functionality to a service that doesn't exist today, AWS Lambda is a very easy way of doing that. We introduced AWS Lambda scheduled events, and I'll talk of that one in a bit more detail But we also have things like CloudFormation custom resources, which allows you to extend the capability of CloudFormation by having one step of your CloudFormation execution as a Lambda function. We also introduced Amazon SWF tasks, which allows you to offload a lot of the task processing. So the decider logic still runs on SWF, but the actual task execution that orchestrates the orchestrated task execution can now run on Lambda. Amazon SES introduced inbound email rules, and you can have separate rules or custom rules created by invoking a Lambda function, and I'll talk of this one too. And lastly, again, in this space too, we have lots of external extensions. So Zapier is a service which allows you to hook up multiple similar web hooks from two different providers. So you can integrate a Zapier to invoke a Lambda function, which a Zap will then trigger a Lambda function, and you can respond to that Zap. And in all of these cases, we do hope that this list continues to grow. Our goal is to make Lambda pretty ubiquitous in this sense, that you can trigger a Lambda function from any service, and you can add the custom functionality, or you can add the data processing workflow to extend your service. So that's about what, that was a quick recap of what AWS Lambda is. From here, what I'd like to do in the bulk of this presentation is to talk through the 5 new features announced earlier this month at reInvent 2015. And I'd like to walk through each of these features in a little bit more depth, talk through what the benefits of these features are, how these features look like, and how you can make use of these features. So I'll go in depth in each of these. The top ones that I'd like to talk about are Python functions. We introduced a new language runtime in which you can write Lambda functions in. We increased the function duration. Earlier, the max timeout that you could run a Lambda function for was 60 seconds, but with this announcement, you can now go up to 5 minutes. We introduced a concept called function versioning and aliasing, making it very easy for you to manage and maintain multiple copies of your Lambda function, so you can have different stages or environments which you can run. We introduced schedule functionality for Lambda, so you can run a cron job on top of AWS Lambda. And also, I'll give you a quick sneak peek into the upcoming feature which enables access to resources behind a VPC from inside the Lambda function. You can find more details at the blog post which I have provided below, but let's walk through each of these in turn. So let's start with Python. We introduced Python 2.7 support in AWS Lambda, which means that Lambda now has a native support for writing Lambda functions in Python. And Python is a language which we have heard was a very top requested language, and we are happy to provide support for users who are excited to write code in Python so that they can migrate over their existing Python applications, which often are big data processing applications or IT management applications. So if the Python is a language that you are used to working in, you don't need to learn any new programming language, or you don't even need to wrap your your Python function inside the existing languages. You can directly write your Lambda functions in Python. And the way it would work is that whenever you are doing the runtime selection for the Lambda function, you would just say Python 2.7 in addition to Node and Java in the dropdown for the runtime. Also to note that we now have all of the blueprints that we have. A blueprint is an easy way, is a pre-configured and a sample code which we provide to hook up to the existing AWS events and make it very easy for you to get started. So all of the blueprints that we have are also available in Python now. So let's look at what it would look like on the console. When you go into the AWS console, when you select create a new Lambda function, you'd be directed to the blueprint screen. If you search for Python, you will see that we have lots of blueprints which are available for you to start processing in Python. So let's look at one of the sample applications that are built in Python, and you will see how easy that is to write. Now I selected the test application, a simple hello world application. As you can see here, the screen is now pre-populated with the runtime selected as Python 2.7, and you have a sample code for the hello world application written in Python. A couple of things I would like to highlight here. One is that the runtime, as I talked about, is selected as Python 2.7. But let's look a little bit more detail into another sample code to show how easy it is to write applications in Python. And here I have taken the code base for the Amazon S3 trigger blueprint that retrieves the metadata for an object and then writes that to the logs. So what I'd like to highlight here is that, as with any other programming language that Lambda supports, you can import existing libraries. So here I'm importing the JSON and the Boto library into the Lambda function. Because these are already included in the Python runtime, you don't have to have a separate file that you attach in here. The second thing, as you see, is that arrays become very easy to address in Python. It's much easier to access a object or a whole dictionary of objects inside of Python, because that's one of the benefits of Python. It makes it very easy for array processing or object handling. So all you have to do is, what you earlier became record 0, and the key was S3. You just have to specify array of S3, which automatically fetches the value of that key in the object. And the last thing that you see here is that it's very easy to raise exceptions in Python. All you have to do is try and then specify the things which you want to do. Here I just logged that content type of the object out there and then return the response. But raising an exception would be as easy as to accept an exception and then print the error message that you're going to get. So as you can see, Python is much cleaner. You don't have to worry about callbacks. You don't have to worry about how you would end a function, because whenever you say return, that becomes the end of the function in Python. Makes it very easy for you to run very complex applications. So that was Python 2.7. Let's talk about the next feature, where we increased the 60-second max time duration of the Lambda function to 300 seconds. The benefit of this one is that this allows you to process much larger objects and run much more complex code in AWS Lambda. Now, we heard customers who are running video transcoding applications or ETL applications on Lambda, and 60 seconds wasn't quite enough. And therefore, we increased this limit to 300 seconds, which allows you to run a wide range of these applications very quickly developed in AWS Lambda. Now, the previous example that I showed, all that did was to take the S3 metadata and log it to CloudWatch Logs. Well, if you're getting an S3 object, you could easily fetch that object, do a video transcode or a file transcode, and then upload that back to a different S3 bucket. Now, all of these applications now you can run for much longer, allowing you to work on much larger files, allowing you to process more complex applications, run machine learning applications or algorithms, create big data processing pipelines, or most importantly, create the ETL applications on top of Lambda, where often the query that you are running in the ETL takes longer than a minute to complete. Now, since most queries we have heard completes within this time frame, Lambda becomes a very easy way of building your ETL applications. And the way it would work is that in the runtime that you select for, the way it would work is that whenever you're creating this application, you just have to increase the max timeout that you see on the function to 300 seconds. And also note that we have an internal callback function called get remaining time in millis, which gives you a response of how much time you have remaining in milliseconds for your function to execute. So if you are building applications which require continuous processing, what you could also do is fetch the time remaining at each point that you have, and if you see that you have less than the number of seconds it would take to complete your processing, you could fork that out as a separate Lambda function, so that your Lambda functions never time out. Now, if you go in and set your max timeout to 5 minutes, and then you set this, print the get time remaining in milliseconds, you should see that you have 3000 as the remaining milliseconds for your execution of the function. So let's look at how to set this on the console. Going back to the previous blueprint which I was talking about, as you can see at the very bottom of the screen here, the timeout function that you set in the advanced settings now allows you to set a timeout of up to 5 minutes. And this is still a configurable timeout. This doesn't mean that all functions run for up to 5 minutes. You can configure this setting to anywhere between 1 second and 300 seconds, or like 5 minutes and 0 seconds that you wish. This is just the maximum timeout is now been increased. So that was the timeout settings. Now let's talk about function versioning and aliasing. I'd like to go a bit deeper into this one. But what this allows you to do is to upload and manage multiple versions of the same Lambda function. So earlier what used to happen is that each time you upload a fresh copy of your code, Lambda used to overwrite the existing Lambda function. So you had only two options, to overwrite or to create a whole new function. But what this feature does is that when you upload a new copy of your function, it simply creates a new version of the function. So if you had a my function one, if you upload a new copy, that becomes my function 2. Therefore, you still maintain both of those copies of your code, and you can manage both of those individually. Also, you can create a named alias and then assign an alias to a specific version number, so that you don't have to call the function as my function 17. You can simply call it as my function :prod. And this allows you to maintain multiple environments where you have a dev stack, a test stack, and a production stack. And then these stacks can keep moving around as you create new versions of the same function. So the way it would work is that now the invoke call, or the Lambda function ARN that is provided to a function, allows an optional qualifier specification, where that qualifier could be either the version number. So you could go and invoke a specific version saying invoke version like my function :17, or you could create an alias and you could just have to invoke the alias calling it my function :prod. Let's walk through what it would look like now before we jump over to the console. So there are three ways in which this works. So in terms of developing new functions, that stays the same. That experience stays the same. So if you don't want to touch this feature, you use the same experience that you have today, where whenever you upload a code or make any changes, the latest update wins, and your development function is always updated. So for example, the way that would work is, let's say you have a user who is trying to create Lambda functions. The first time the user says create function, and let's say all this function does is returns a string, and the function is named my function. So when you invoke my function, that's the function that's going to get invoked. However, when you call the create function again, or update the function code, what's going to happen is that update is going to overwrite that function code. And let's say the new function, the new code that I'm writing returns a different string. So the next time when somebody calls the invoke my function API without any qualifier, it is not going to invoke the first function. It's going to invoke the second function, because that function has now been overwritten. This is the default behavior, and you can continue to use this behavior today. However, instead of using the update function code, there is a different way in which you could do this with this feature. So in here, this is publishing new versions. So instead of overwriting, you can create a new version. So you overwrite your latest development version, and then you copy that development version to a numbered version using a different API call. And every time you publish a version, the entire function code and configuration is an immutable copy of your function state, of your development function at that time. So once you have published the version, you cannot change the version code or the configuration. all you can do is change your development version, your development code, and then publish yet another version if you want more changes to be done. And the versions, we have a simple integer count per function, which is automatically added. You don't have to worry about it. Every time you say publish a new version, we'll create the next integer version of that function. So to explain how that works, again, let's take that example where user is deploying Lambda functions. When the user takes the development version, which at that time says the code is return version 1, and you say publish version, that will create my function :1. So then when the user goes and calls invoke my function :1, it's going to invoke that copy of the function. Now let's say the user goes in and calls, it creates, you can go in and change the deployment version to have a different string which is being returned, and you go and publish another version with this deployment code, with this development code. Lambda will automatically assign a version number 2 to this function. So now when the user calls invoke my function :2, they will invoke the second version of the function. But if you note, the user can still go in and invoke version 1 of the function. The version 1 is not overwritten. You can now invoke both versions separately. And the third step of doing this is creating aliases for functions, where if you don't want to call these function versions, what you can do is that you can create an alias, where alias is effectively a tag which is mapped to a specific version number. So the benefit of this is that this tag is simply a pointer, which means at some point the prod tag can point to version 6, but if you keep developing your function, you want version 12 to become the new prod, you simply change the tag. You don't have to update the client that is calling that version. And of course, the development version gets the default alias of $latest. So if you want to specifically call your development version, you can just call my function $latest. So again, how that works is that whenever a user says, I have a specific version like v1, I want to call that as prod. And then the user, instead of calling my function :1, can call my function :prod, which would invoke v1. And you could call v2 as beta, and then if the user invokes my function :beta, that invokes v2. And the benefit here is that at some point you can change these tags. You can have prod to point to version 2, and therefore the client application, which is still calling my function :prod, now has access to the latest functionality. So let's look at how to set this up on the console. So jumping over to the console, as you can see here, whenever you are creating a function, here I have a function where I've already created 3 versions, and I'm editing the latest version of the function. So as you can see here to the left, I have a couple of versions that I have created, and this is where you will see the versions of the functions that you have, your existing versions. At the top right, when you go into the actions button, and you can say publish a new version. So what this will do is it will allow you to create a copy of your development stack. The development, as you see, was the latest, was the $latest that I was editing. I go and say I want to snapshot the $latest into version 4. So I go and give a version description, and when I say publish, as you can see, the :4 has been popped up. And now because this is immutable, the console won't let me edit this function anymore. Version 4 is a read-only function. Only $latest is the one that you actually edit. So as you can see, version 4 is the one that I'm actually have open in my console right now. What I can also do is go to the configuration of that function and then create an alias for this version. So when I say create alias, let's say I'm going to call this my development version, because I want to continue to my developers to hit this version when they are testing their functionality. So I can go and create a alias called devo, and the version that I select in here is version 4. When I click submit, you'll see that the aliases are now showing up, and version 4 is actually pointing, the alias called devo is now pointing to version 4. But as you see here, that version that an alias points to is configurable. I can go into the drop-down and have my :devo point to a different version in my function. So I can have devo be the same as version 2 if that's what I want to try out right now. So that was function versioning and aliasing. Let's jump over to schedule functionality. What we have introduced earlier this month is the ability to invoke and run Lambda functions on a schedule. So event sources that we were talking of that used to be data plane events can now also be a cron event or a cron trigger that invokes the Lambda function, which makes it very easy, in a completely serverless manner. All you need is one service. All you need is AWS Lambda to run things like batch jobs, periodic cleanup jobs. You want to do periodic data aggregation. You want to go and fetch everything off of a queue every few minutes. You want to create a monitoring job where you are building a Canary. Anything that runs on a recurring schedule can now automatically run as a trigger in the Lambda function, and you can have your code do what you need it to do. And the way it works is that when you're selecting the event source, you can select schedule event from the drop-down. And this functionality today is available only in the console. The API and CLI versions of this are coming soon. So when you create that the drop-down, and you can go and select either cron or rate as the options. With rate, it invokes the function every X minutes. The least count today is 5 minutes, and we hope to reduce that over time. Or you can specify a full cron expression where you want a function to be invoked, for example, every Monday to Friday of October, and that's all you need. Then you can go and specify that as a full cron schedule. So again, to quickly show how it works, we have a blueprint which we have set up for this. If you search for cron or for Canary, you will see this blueprint. And what the Lambda Canary does is that if you click on that one, you will see that it has the scheduled event as the event source pre-configured. You can name, as with every other event source, you can specify what you want. I'm selecting a schedule expression to be every 15 minutes, but you can choose whatever schedule expression you want it to be. And it has a predefined code for you that runs a Canary that pings your endpoint and checks the health of that endpoint. Let's look at the code a little bit zoomed in. Here's a code for running the Canary. I don't want to do a full code walkthrough, but I'll highlight the important parts. The first one is that you specify what the site you want to ping. Like this, here I'm going and building a Canary that pings Amazon.com and searches for the string online shopping. If what I'm checking is that if online shopping exists in this site, then the site is live. If I can't find this string, then there's something wrong. So what happens is that when the Lambda function loads, is invoked every 15 minutes, the first thing it will do is it will try to validate that site by doing a URL open, which basically is a curl for Python. And if it doesn't find that string, it'll raise an exception. And effectively, what the validate function does is that it searches for a string in the actual curl response that you're getting from the result. And as long as the string is found, it will go and print, check passed, and it will return the time when it passed. And if something fails, then it will go and check. It will say check failed. And right now, all I'm doing here is logging these results to CloudWatch Logs. But you can choose what you want to do in the exception case. If you want, you can page your on call. You go and say, something is wrong with our site. We need to go and look at it. And the last one I want to be talking about is a sneak peek into what the VPC functionality that we'll be doing, which is coming soon. What this allows you to do is access resources behind your existing VPC from inside the Lambda function. Now, Lambda functions today run in the VPC, but it is a Lambda system managed VPC. What this functionality will do will allow you to access resources behind a private subnet in a private IP range within your VPC. So you can go and talk to things like in MongoDB clusters on EC2, or you want to talk to your load balancers or your RDS tables to fetch some information, or you want to use Elasticache for some sort of cache management or state management of Lambda functions. All of these can be done in a private manner without leaving your private IP range. And the way it would work is that when you create the Lambda function, you would be able to select a VPC subnets and security groups, and then Lambda function will effectively invoke inside that subnet. So it will take IP addresses from that subnet, and then it will invoke it invokes. So now it can talk to those the resources behind that subnets, and it will also follow the rules of the security groups. So you can very easily manage the ports that it can talk to. You can manage with a single click of the security group. You can say what this and this cannot talk to. This is still in development feature, so I don't have a full console experience for this, but just as a sneak peek, here's what this would look like. Now what I'm doing is get function configuration, and this is a function which I have on my development stack. And as you can see here, the two things I want to highlight is part of the function configuration are going to be the subnet IDs and the security groups. So when you create the function, you specify these subnet IDs, and these are now associated with a specific function. So that this function, whenever it's invoked, it will only be able to talk to these subnets, and it will follow the rules of the security groups. So that's what the VPC feature is going to look like, and that's coming soon. I have a few other quick highlights I want to let you guys know about in case you missed these updates. First is that we have new partner blueprints. So we have lots of Amazon partners that we are working with AWS Lambda partners we are working with, and we have blueprints to use the functionality or to extend the functionality of AWS Lambda using these partner blueprints. But Algorithmia is a marketplace for algorithms, so you can very quickly build smart applications. If you don't want to own the IP of, you don't want to run the actual face recognition, you can simply call a face recognition algorithm from Algorithmia to do that for you. Splunk is a data insight service where this allows you to do is push all of your user logs to Splunk instead of to the CloudWatch logs if that's a logging partner of your choice. Now Amazon Echo is the one that I talked about. Now we have a simple blueprint that demonstrates the basic skill that you can build with an Alexa skills kit. And Twilio is another blueprint which we have, which allows you to create a simple backend for handling events sent from Twilio to create intelligent IVR systems. So I'd encourage users to try these out. Another one that I wanted to highlight, because we announced this shortly before reInvent, is the Amazon Simple Email Service inbound rules, where you can set up pre-canned rules right on the Amazon SES console. But what you could also do is you can create your own rules by invoking a Lambda function in response to every incoming email. And the one that I have here is a simple spam check, where you might want to use this inbound rules that you have over here and create a spam notification. But what users have also built using this are applications where an incoming email, you strip out the attachment, upload that attachment to a stateful data service like S3, and then include the URL of that attachment inside the email so that the user's inboxes are not flooded with large attachments. So any such custom activity for every incoming email that you want can now be built using Amazon SES and Lambda integration. Another one is the ability to process CloudWatch logs. The CloudWatch logs earlier had a service called CloudWatch Log Subscriptions, which would allow you to publish data onto a Kinesis stream. But CloudWatch logs also announced the ability to pump logs directly into Lambda. So if you have your whole system, your infrastructure, which is publishing your logs to CloudWatch logs, you can feed those logs into Lambda systems into Lambda to run a scanning or auditing or overall index logging entries for your logs in near real time, and push these to downstream services depending on what you want to do with them further. And the last one I want to talk about in this space is the IoT integration. So AWS IoT is a new service which we announced again earlier this month, which allows you to very easily interact with your existing IoT devices by creating a device registry or a device shadow on the cloud, on AWS, and then using different authentication and message broker services to push MQTT responses coming in from your devices, which can then go and talk to the rules engine that we have. So what then happens is that rules engine can integrate with other existing AWS services. The device shadow makes it very easy for you to, because now the devices have a shadow on the cloud, you don't have to have the device always responsive. In the system, on your application, you only have to talk to the shadow, and the shadow will go and synchronize itself with the cloud, with the end device, whenever the network availability is there, or whenever it feels the best time is for synchronizing this, and these messages go over MQTT or even through HTTP. But the rules engine is something where you can go and try to create a response or a trigger or an action that will respond to every device input. And the one I want to highlight is that you can have a Lambda function that responds to these rules engine rules, which makes it very easy for you to respond in near real time in a horizontally scale out manner without having to manage any infrastructure of what you want to do in response to the IoT device. So in summary, we have 3 next steps for you. First, we encourage you to create and test your first Python function using AWS Lambda. As we saw, the writing Python code in Python is extremely simple. You can make use of extension libraries or Python modules and for running data processing routines on Lambda. And especially with the larger function timeout, you can run more complex algorithms that take a long time to analyze your data as a simple Lambda function too. Next, give Lambda function versioning and aliasing a try. Create multiple versions of your Lambda functions and assign different aliases to those versions. Now, the whole aliasing and versioning is completely free, so you don't have to worry about that. Now, try hooking this up to Amazon API gateway methods and try to map your API versions to AWS Lambda versions and let us know how that experience is. And the last, but in no way the least, I recommend you to hook up your Lambda function to a scheduled event to create a Canary that monitors the health of your infrastructure or any other public endpoint that you are interested in. Remember that the first 1 million invokes per month are free. So Canary that pings every component of your setup every 5 minutes and warns you or pages you or sends you an SMS notification as soon as something is down is going to be absolutely free for you. You have to use only one AWS service, that is AWS Lambda, and this is going to be a completely free setup for you to go and build your canaries. So start hacking away today. So with this, I thank you very much for listening into this webinar. I hope you found this is worth your time today. At this point, we'll take a quick 2-minute break. When I return, I will address some of the common questions brought up in the Q&A panel that Ajay has been addressing so far. Okay, thank you.
Great. Thank you, William, for the presentation. And audience, as you can see, there are 3 poll questions to the left of your screen. Please take a moment to let us know how you feel about today's presentation. Ajay has been answering your questions and assigned a few to William. William will answer them momentarily. Thank you.
Okay, welcome back. I'll go through some of the top questions which have been asked. I have a question from Akash. What's the best way to supply credentials to external resources? Now, at this moment, I bundle these into the zip file. Is there a better way? So for any credentials that you are using to external services, we recommend you to use a service called Amazon KMS, a key management system. What this does is it allows your actual source code to hold only a private key, where your source code at that point using the private key can call the KMS APIs to convert that into an encrypted secret passkey, which holds the actual credentials to your end system. So this way, even if your source code is accidentally posted to a public GitHub repo, or is accidentally leaked, you don't leak your actual credentials, you only leak your private keys, and nobody can do anything with those private keys. As a reference example, now we'd encourage you to look at either the Algorithmia or the Splunk blueprints, because we have credentials, we have user credentials to Algorithmia and to Splunk embedded in these blueprints. We have presented a way in which you can host these credentials using KMS. I have a question from Sai Kumar. What's the difference between Amazon EC2 container service and Lambda, and when do we use each of these? Amazon EC2 container service is an easy way of running your Docker-based, container-based applications on top of Lambda. The container service has two main components, one of those being a cluster management, where it helps you manage your existing Amazon EC2 cluster of instances which are going to be used to manage your service, and also in terms of the scheduling, where it decides which task runs on what cluster. So Amazon ECS is a very lower level service where you still own and manage all of the infrastructure. You still own and manage the actual machines on which it is running. So you have to manage the EC2 instances, you have to manage what task runs where. The scheduler simply is a placement engine where it also can decide what the state of your system is and therefore respond to state events. So if you're trying to build a very DIY solution using Docker-based applications, then ECS is the best way of doing this. Lambda, on the other hand, is a higher level abstraction service where we abstract away all the underlying infrastructure. So if all you want to worry about is the end application, and you don't want to go to the level of hardware trying to figure out what the best hardware to run on this, trying to figure out how to scale your cluster. If you don't want to worry about all of those and worry only about the application, then Lambda is the best way of creating those applications. I have a question from Tyler. Is it possible to configure Lambda to execute after receiving some number of events instead of on every single event? So there are a couple of ways in which you could do this. The triggers which you have are always going to be on a per event trigger, especially when you are using services like SNS, S3, or API Gateway. What you could do is that with Amazon Kinesis, which is a stream management service, you have an option of selecting a batch size of how many requests that go in each invoke of the Lambda function. Now, while that is still a max batch size, which means that Lambda will still try to invoke as fast as it can, but if there is more data, it will pull lots of records together and process that whole batch of information together. So you can use Amazon Kinesis as a way of arbitrating, as a way of your events go into Kinesis, and then Kinesis hooks up to the Lambda function. So Lambda can pull on a whole batch of data from Kinesis. That's option one. Option two could be with the scheduled events that we just announced. You can set up a schedule that wakes up every 5 minutes and pulls all the existing information that you have in those 5 minutes and processes everything together. So this allows you to batch up your records in a time-bound manner rather than a batch size manner. So those are the two options that you can have to invoke your, to have a number of records, a number of events being processed together. I have another question here from Mark. Can your Lambda code result in an infinite loop that goes RE? If so, how could you kill it if you have no access to the server? Yes, it is possible for Lambda to have an infinite loop, to go into an infinite loop if on user error. So for example, if you have an S3 bucket as an event source, and that triggers a Lambda function, and in that Lambda function, if you're writing back to the same S3 bucket, what's going to happen is that that's going to create an infinite loop where every put to the S3 bucket becomes a Lambda function, writes back to S3, which becomes the next event, which writes back to S3. So that infinite loop is possible. So what we do recommend as a best practice is always to use either separate buckets or separate input and output destinations, or to at least set up the filters. We have prefix and suffix filters on S3, and similar events that event sources that can trigger the Lambda functions, to use at least those filters to make sure that you are not doing something of this sort. However, you don't really need access to the underlying server to kill everything. All you need to do is disable that event source mapping, and that infinite loop will die. You just need to break at some point one of the links of the infinite loop, and that loop will fall apart. Nitin talks about a very specific use case which I'd like to address. Now he says he needs to shut down and start EC2 instances based on date and timestamp of the instances. How can we leverage Lambda for this? So again, what you could do with the schedule functionality, you could set up a cron job that goes and every 5 minutes it wakes up and pulls the state information for all of the existing EC2 instances. You could do a describe instances call and find what the state of existing instances are. And you could have a separate stateful service, something like DynamoDB, which stores the state information from previous calls and also information on what needs to shut down when. And you can compare the current state versus the expected state from the stateful service, and you can have the Lambda function take actions correspondingly. Okay, we are at the hour, so to respect everybody's time, we will close the Q&A panel for now. Feel free to continue this discussion and post your questions which are unanswered to the AWS Lambda forums. We'd be happy to address them. So thank you everybody, and wish you a very happy Halloween.